Hey guys, how's it going? It's your boy Amir, and today we are going to be looking at IPFS with Python. IPFS is basically Interplanetary File System. There's not a lot of videos about it. In fact, there are a few very good videos about it, and that's about it. So I thought I'd add a little bit to the documentation, add what I could add, and if you're a Python dev, learning IPFS using this video should be really easy for you. I'm using slides to kind of streamline my thought. There's also going to be a little bit of coding in this video involved, so like get your Vims ready, get your terminal ready, and let's get started. So we'll be talking about a few topics here, which is what is IPFS, how is it different from databases and torrents, installing it in your system, running a peer, connecting to IPFS, uploading, fetching, and where to use IPFS most importantly. The prerequisites for this video are knowledge of how basic internet communication works, like HTTP, and knowledge of a basic database, and knowledge of basic data structures, and basics of Python. Also by basic data structures, I mean you should know what a data structure is. Here you should know how HTTP works, and you should at least know what the client server model is. Basic knowledge of a database means that you should know how database works, like when to use it, how is it different from a data structure, and some basics of Python, which is functions and importing libraries, because that's how we'll be doing this video. So what is IPFS? IPFS is essentially a file storage system, and if you've ever used a central database before, like MongoDB or PostgreSQL, you'll know that usually for smaller applications you'll have just one database. For larger applications you'll have something like a cluster of databases, right? But when you ask your user to use any of your any of your services, you'll essentially ask them to use the central database, like they'll communicate with the central database. In an IPFS, what happens is every node, every peer, every server, whatever you want to call it, all three basically the same thing, that is running the IPFS network, will essentially host a part of the data, right? And I'll get to how that works. So every node that is participating is also a server for data storage. Data is requested using cryptographic hash of that data instead of IP address. So you'd in an IP address you'd have something like, hey, for example, for Facebook it'd be something like 2732.129.232, whatever. Like that's not a correct format, but that's how you would have your IPv4 IP address, right? Here it's basically a cryptographic identity. It's a content ID, which is basically a cryptographic hash of the data. And now how does that happen? We'll talk about that sometime later in the video. It's essentially you are making a hash of the file buffer. Now I know you don't understand that if you're not privy to what a file buffer is, but we'll get to that. Which means that if you're referring to content by its hash, there will be no two same files uploaded. If you have one test.txt which says test inside and another test.txt which also says test inside, essentially they'll have the same cryptographic hash, which means that they'll not be re-uploaded, they'll just be referred to again. Each node, server, peer has an ID. So in a few minutes I'll start my IPFS client and you'll know what I'm talking about. So how does IPFS store data? Before I get to that, let me try and upload a file on IPFS. So I'm using OBS Studio, and in this version of OBS Studio, for some reason I can't record my entire screen. So what I'm going to be doing is I'll just be recording my Chrome screen, and in the background, what you can't see is that I installed IPFS from the official website, and then I ran the IPFS desktop client, because you don't need to know why, but I started the desktop client. You could also use the CLI, which is the command line tool, to start the IPFS daemon. All right, daemon, I don't know how to call it. Then I installed something known as the IPFS companion for my Chrome browser. You can also have this for Firefox, you can have this for wherever. And once you start that, so if I'll shut it down back again, let me just shut it down back again. you'll see that it becomes gray, right? And IPFS is not running. Now you can't see this part because OBS is not capturing it, which is it's a recording tool. So I'll just start it off again, and you can see that it becomes blue again, or emerald, or cyan. I don't know what color is this, but it becomes that color again. And it says your node is connected to two peers. So let's have a little bit look around on how IPFS is working right now. And I'm using something known as the IPFS web UI. You can also do this entire thing from command line, or you can have your own UI. You can do it via Python, JavaScript, Go, Chapel, whatever language you want to communicate with IPFS. You can do that in that language, but I'm using the web UI right here. Now let me try and fetch something from the IPFS, something from before right here. All right, I do have. So I loaded this random data. Let me see what this data is. Right, it says test. So I had uploaded this earlier, earlier this morning. It says test. So this is what I had uploaded. Now this is the content ID, and /IPFS/content ID leads me here. Now I have some metadata over here that we'll talk about in a minute, but let's see how this data, this test data, is stored. All right, how does that sound? How many KBs is it? It's 12 bytes. So let's get back to the slides. So how does IPFS store the 12 bytes of data, right? What basically happens is when you add any content on the IPFS network, the data is split into chunks of 256 kilobytes. And these chunks are then distributed to various nodes on the network. Kind of like how torrents used to work, but not exactly. Now suppose there are three peers with peer IDs 48, 10B, and 603C. Now when I started my IPFS client, a peer ID was given to me as well. Now so suppose a 768 KB data, and this is basically 256 times 3 data, is stored on the IPFS network. Now the data is broken into chunks of 3, and each chunk will be 256 KB, and each chunk will have a hash, right? So that hash will now basically be compared to the peer IDs, and the hash that is closest to the peer ID of, suppose you remember that we had 48 and AB 603C. It will compare the hash of the chunks to the ID of the peers, and then it'll basically match. And if they are lexically close, by that I mean 42 AB is kind of close to 40A, but not as close to 10 AB. So this will go over here. You get my point? Now these three chunks are sent to the peer ID with the ID closest lexically to the hash of the respective chunk. And then the address is updated in something known as a distributed hash table. Now IPFS is written in Go. I'm pretty sure the developers implemented the distributed hash table inside, and distributed hash table is basically just a hash table which helps in locating the value of the asked key. Think of a hash table as something like a dictionary, but not quite. I mean, the key value pair is there in a dictionary, in a hash table, but it works slightly differently. There's something known as the hash function. So when you upload a data, it goes through a hash function, and then you get a key, and that's kind of how it works. But then there's like hundreds of types of implementation of a hash table as well, but I'll leave some links in the description to how a hash table works. You can probably read through it. So how does one retrieve data on IPFS? Now we already did this, but I'm just going to read this out really quick. You basically do /IPFS/hash of the data, and it'll display in the browser using your browser's protocol. You can also fetch it via a gateway, and we'll talk about this in a second. Let's get to some coding. How about that? So first of all, download and start IPFS client. Go to download IPFS. You'll notice one thing right here. I'll just show you. I'll go to install IPFS. So this is pretty cool. Alright, it's not loading. So what I'll do is basically I'll stop IPFS right here. So what it was trying to do is basically fetch the website from the IPFS network, but it was very slow for some reason. So we'll just load it via normal HTTP request. I'm sorry for the delay, ladies and gentlemen. So I'm presently using Windows. You can I tried it on Mac, it works perfectly fine. I tried it on Linux, it works perfectly fine. And then once you download this, you can download something known as the companion, which is this thing right here. And then we'll go about talking about how to basically interact with all of this in a second, right? So download the client and start it, and you're good to go. Now the next thing that we want to talk about is the IPFS HTTP client, and I'll just add a new window capture here. So it'll take a second to install, and there we go, guys, it's done, I guess. What we'll do basically is import IPFS HTTP client, and then we'll connect to it since it's running. Whenever you have IPFS running, you'll essentially have a slash HTTP kind of thing in your daemon or in your companion, wherever you go. And we'll kind of connect to that using Python right now, right? Usually it's this localhost /tcp/5001/http. So I'll start off Python right here. Just put this back into display. Oh, this is visible. All right. So let me just do this really quick. Let me import IPFS HTTP client, right? And let me just connect to this. I'll just copy paste this. All right, so now we have connected to IPFS HTTP client, and I'll just print this right here. Right, so we have a client object ready. Now what we essentially need to do is add a file, and then we'll get a file from over there. I'll basically add out.txt to the IPFS network using my amazing coding skills. So let me just type in out.txt. Right, we have it. Let me just print res, and this is the content ID of it, right? So what I did was client.add out.txt, and there we go. Now I'll just go back to my OBS studio and make this disappear for a second. How do I restore the size of this thing? Alright, so I have it right here, and I'll click show on gateway. So this is here right now, some news that I had, like I was using PyTestRack to fetch some news, and this was the output file, and I have added it now to the IPFS network. Let's go back here and let's talk about was that visible? Let me just check. It wasn't visible. So yeah, this is what it was. Let me just go back to this. Is it's fine. So we have now uploaded a file. We have checked the file. This is the file metadata that I was talking about, and we viewed it from a gateway. Now there are a few public gateways. Gateways are basically systems that are not ours, that are running, that someone else is running, and we are using that gateway, so to say, quote unquote, to fetch our data, right? Let's go back. Let's see how this is. I like Camtasia for the reason that I can, do all of this without fumbling around too much, but Camtasia is not installing. Yeah. Anyway, so there are 4 or 5 gateways. I'll add them in the description. Let's fetch the content ID, right? And we'll have to use the decode format. So we'll go back to our trusty little PowerShell. I miss my Mac sometimes. It's a great piece of hardware, but it's not working for me right now. It's having some issues. Alright, now let's retrieve a file from the IPFS network. So we have already uploaded a file on the IPFS network, and it should be easy to get it back. We'll be using something known as the cat function, and I had to stop the recording in the middle, and now I've reconnected to my IPFS client from Python. It's going to be get file is equal to client dot cat. I'm just going to paste it here. Alright, so let me just print get file. Right, so you get b test. Now what I want to do is that I want to decode this. This is an UTF-8, I think. So I'm just gonna go with get file is equal to get file dot decode. It's UTF-8, and just press enter. And let's so you get your test back here. I don't know. So anyway, let's get to IPFS use cases. For more documentation, obviously go to IPFS shipyard / the IPFS HTTP client for Python. There are other clients, you try to use that if you want to. Yeah. So the use cases are basically distributed storage and blockchain applications, since blockchain applications are heavily restrictive in terms of what amount of data you can store. For non-tampered web services, because you can't tamper IPFS data, because if you tamper it, the content ID changes, and better content delivery networks, because it is hash based, so there's no duplication, there's no tampering, it can be faster in some cases, and there's a lot of other exciting prospects for it as well. And also there's 100% uptime for IPFS networks. So anyway, that was it from my side. Thanks. I'm everywhere as Abhinav Mir. Sorry for the little hiccups here and there. It's because my OBS studio is not working properly. I guess I should have my Camtasia back up soon, and I didn't want to delay, because there could be a lot of people trying to get into this field but not finding the right documentation. So I thought, hey, you know what was that code? It basically means deploy it, but it's okay if it's not perfect, just put it out there, so that's what I was trying to do. Anyway, thanks for tuning in, guys. My name's Abhinav Mir. It's actually Abhinav Shrivastava. You know why I don't use Abhinav Shrivastava. Google it, you'll understand. And that was it from my side. Let me know what you guys thought of the tutorial. If you have any questions, let down in the description below, and we'll talk next time about some more interesting topics. Thanks for tuning in.